hello and welcome. I'm pleased to welcome you to today's masterclass session dedicated to SAP Supply Chain Excellence, brought to you by Kerber Supply Chain. My name is Thomas Goldsby. Our today's session, we're featuring a duo of speakers that I'll introduce in a moment. The session is titled Automating Your Warehouse with SAP EWM and SAP MFS. My name again is Thomas Goldsby, and I am a professor of supply chain management and chair of the logistics at the Haslam College of Business at the University of Tennessee in Knoxville. I also serve as the co-editor-in-chief of the Journal of Business Logistics. I'm joined today by Mark Vogt and Thomas Schmidt. Mark is head of international sales and marketing with Kerber Supply Chain Automation. He has 25 plus years of experience in consulting, sales, and project management for intra-logistics automation. Thomas is sales and marketing manager for Kerber Supply Chain. Like Mark, he has more than 25 years of experience in the logistics IT industry and specializes in operative logistics and automation integration with SAP solutions. Welcome, Mark and Thomas. It's great to have you with us today. I'm going to turn, sorry about that. I'm going to turn things over to our subject experts in just a few minutes, Mark and Thomas, after I cover a few items. First, you might be wondering, why are we here? What is the purpose of this masterclass? Well, the purpose is to tackle the challenges of today's increasingly complex supply chain, bringing you best practices and innovative thinking from academics like myself and industry insiders and senior leaders like Thomas and Mark. What are we trying to accomplish? Well, we want to provide guidance and insights in managing your supply chain as a competitive advantage. This masterclass is dedicated to SAP Supply Chain Excellence, and we'll be exploring the ways in which companies can most effectively and efficiently deploy the capabilities of SAP's suite of supply chain solutions. Today, we're going to take a deep dive look at the integration of automation with the aid of EWM and MFS solutions in SAP. You see that this is the fourth session of 5 in this masterclass series. Our final session in this masterclass comes around on Tuesday. Note, though, that we have a catalog of recently completed masterclasses that are also available to you on demand, as this session will also be available on demand once we complete it. And you may review any of these sessions. Each masterclass consists of 5 30-minute action-packed sessions dedicated to contemporary topics in supply chain management and advanced technologies. So with that understanding, let's quickly go over some housekeeping items. As indicated, all phone lines are muted for the purposes of recording today's session, so don't worry about any background noise you might have at your home or workplace. We can't hear any of it. However, we do want to hear from you in the form of questions. If you have a question at any time during the session, please go to the GoToWebinar menu and find the Questions tab and type in your question, and I'll make sure it gets to Mark and Thomas at the close of their comments. Also, we have a special handout for you today in the Handout tab, the GoToWebinar menu. You'll find a case study featuring a company called Housekeeping in Germany, a manufacturer that was very successful in implementing EWM and MFS in their distribution operations. So I encourage you to download that, access it, share it, and take what rich insights are available in that case study. Let's go ahead and frame up today's topic. And again, we're focused on automation today and linking it up with SAP suite of solutions. And here you see the very robust market expectations for warehouse automation. The market presently is estimated to be about $15.5 billion US in the year 2020, with expected very robust growth of 11.7% cumulative annual growth rate through 2025, where the market is going to almost double by the projections afforded by Logistics IQ, the market research firm from which I borrow these data. It's expected to be about 27 billion in 5 years' time. Now, I should point out that includes a wide array of warehouse automation technology. And it also includes the spend not only going toward the hardware, but also the implementation and integration as well. So this is a rather holistic number that we see. And even though those are very robust growth numbers, it could be more accelerated than what is depicted here due to surges in e-commerce during the COVID pandemic. So if we can take a look at the next slide, we'll see some various explanations. As I just indicated, e-commerce fulfillment is the biggest factor driving the adoption of warehouse automation technologies presently. And there are some other forces at work suggesting that we might want to take a closer look at automation, advancing any plans we have, or perhaps further investing in automation depending upon the state of adoption in your particular business. We're seeing high warehouse rents, a shortage of skilled warehouse staff, and increasing staff costs that are driving higher adoption, along with, again, the surge in e-commerce around the world. With regard to the specific technologies that are expected to have the highest share of warehouse automation spend by 2025, 5 years from now, well, we see automated guided vehicles continue to be an area of interest, but increasing focus on autonomous mobile robots, AMRs. Also, automated storage retrieval systems, ASRS, continue to be an area of interest, as are automated picking technologies of various kinds. With that in mind, I'll also just point out that our next masterclass session is dedicated to voice picking. So come back and join us on Tuesday in our next masterclass session to learn a little bit more about voice pick support. But let's bring it back to the present. We have Mark and Thomas on hand to lend their insights, and I wanted to direct this question that you see at the bottom to our two subject matter experts. What does it take to direct this automation, and how do you get there? So what does that look like, and how can we get these technologies to interface SAP's WMS and warehouse management control solutions? And I think that's where you want to take the conversation today. Mark, if you are ready, take it away.
Yeah, thank you very much, Tom. Thank you. Yeah, a warm welcome also from Thomas and my side. It's a pleasure for us to be here and to give you some insights concerning SAP and automation. The first slide, we would like to bring you into the subject. If a customer would like to automate his warehouse, if a customer would like to automate his intralogistic or logistic operations, there are different criteria, different puzzles to solve and to create the best solution, so to create the best and most optimized picture. So first of all, a customer has to choose the right implementation partner for the automated solution. Implementation for software, for all the technical equipment, and also the right partner for finding the best solution, the best concept. That's a very important point to find out what are the requirements to such a solution, and then to create the best concept, the best solution. And then, for example, the best solution could be a hyper warehouse, a fully automated hyper warehouse. The best solution could be a mini load system, so an automated warehouse for boxes, for small parts, or even a combination out of it. So that's one puzzle to solve. And then there's also a question, what kind of technology is needed? As you already mentioned, Tom, there are different technologies on the market, like AGVs or conveying system or monorail system, and you have to choose the right technology to solve the requirements and to find the best concept. And another topic is, what will be the right IT architecture? What will be the right topology for such an automated solution? So on the upper level, you have the ERP system of a customer. Then you will need a warehouse management system. Then you will need a material flow control system, and then you will have all the automation on a PLC level. And if a customer has SAP, there will be different opportunities to bring SAP down into the world of automation. And that's the topic of today, what Thomas and I would like to explain, to give you some insights on how we can solve that, how we can bring SAP into the automation level, and what might be the best solution to do so. So that was just the introduction of the slide, and Thomas will go ahead with the different opportunities we have.
Yes, before we start with the different opportunities, I will give you a very short introduction to the material flow control system, the MFS system of SAP, and we'll show you what is the way SAP EWM will work. So the main task of a material flow system or warehouse control system is to control and optimize the movements in automated warehouse. The material flow system of SAP EWM, the MFS system, enables you to connect up an automated warehouse directly to SAP warehouse management without the need of any additional systems or interfaces to control the warehouse. With the MFS, you subdivide a warehouse task. I give you an example. If you have a task to bring goods from the goods receipt area to a storage bin, and the MFS will divide this task in smaller tasks. The smaller tasks are passed step by step to the PLC, responsible in each case using the telegram communication. So you see an example of a warehouse on the left-hand side. You see the layout of the warehouse, and in my example, forklift driver starts with a pallet on his forklift and drops off the pallet to the conveyor system. You see it on the left-hand side. The yellow box is the starting point of the pallet in the automated warehouse. The PLC moves without any communication to the EWMFS system. Moves the box or the pallet to the first communication point. In our example, this is the communication point A. And at this point, the PLC sends a telegram to the EWM MFS system with the HU number, the communication point, and other informations like the weight of the HU or the height of the HU. The MFS checks the data from the PLC and determines the next communication point. For the determination, the MFS uses one of the key elements of the EWM system. This is the layout-orientated storage control. You see it on the right-hand side on the slide. And if we start with our process, this is the number one process. If the pallet or the box is on the communication point A, and the destination is A2, then the next communication point is point C. And this is a simple table in EWM. And with this table, you can find the way through the warehouse through the conveyor system. And in our example, we are starting at point A. Our target is A2. We have the next communication point C. The PLC becomes a telegram from the EWM MFS system to move the pallet from point A to point C. After execution of this movement, the PLC sends back a telegram to the MFS system, and the MFS system checks the data for the telegram. In our example, is this the point C of the telegram, and we determine the next step for the put away process. The next step in our example will be to finalize the put away to bring the pallet or the box from the point C direct to the bin in the L2 of the warehouse. And for that movement, there is no conveyor system needed. There is a stacker crane, and the stacker crane is another resource in the EWM system. And the stacker crane is optimized by EWM, so the telegram or the movement for the stacker crane will go in the queue. You see it on the right hand side. We have a queue over the stacker crane, and with all the movements in the stacker crane queue, the MFS system is able to optimize the movements to have an interleaving system with alternated inbound and outbound processes with one stacker crane. This is only a very, very high level introduction to the MFS system, how it works. And it's very simple. We have a communication point, and we have telegrams from the PLC, or the communication between PLC and the MFS system, and the MFS system decides which is the way to the next communication point. This is really very, very high fly. In detail, it's more details are necessary to handle that. So in the next slide, we see the typical IT scenarios for SAP-based automated warehouses. In all the scenarios we see on the slide, we have a top-down level organization. On the topmost level, we have the ERP system, following by the WMS system, in our case, the EWM system, followed by the material flow system, and bottommost, we have the PLC level to execute the movements with the PLCs, the physical movement with the PLCs in the warehouse. And you see, one of the biggest advantages of SAP EWM is the integration of processes starting in the ERP, going to the EWM, executed by the MFS system, and go back to the S4 HANA system, to the ERP system. And the big advantage is to have all the processes in one system. And for this case, the embedded EWM system, you see it on the left-hand side, is a full integrated scenario. But there are reasons to split off the EWM system in a decentralized system with an interface to the ERP system. You see it on the second from the left side. You see this scenario, and in this scenario, we have an interface to the ERP system, and we have a decentralized EWM system. The reason for doing that is to have more performance, to have better availability of the system, and you can better support the automated processes in the warehouse. And the next two scenarios, we have an external material flow system. In the third scenario, the external MFS system is partially doing tasks, not for the whole warehouse, only for the partial warehouse, for some equipments that need special performance requirements. And on the right side, we have an external MFS. We do nothing in the ERP system or in the EWM system. Which scenario is the best depends on the level of integration. Is the highest level of integration is with the embedded EWM system on the left side, or you have requirements regarding the complexity and the performance. And if you have the highest requirements, the solution with an external material flow system will be the best solution for you. We will show you some examples from real projects, and Mark will give you with the next slide an overview or a first example.
Yeah, so the question is, which scenario is best for a customer? And the answer is not so easy. So there are different criteria you have to answer to get the decision for the right scenario. And to give you an example, for a fully integrated SAP EWM MFS solution, this is a mini load system project we have done in Poland. It's a fully automated warehouse for boxes, for smaller boxes, different sizes of boxes, and in the boxes we have small parts in it just to deliver some equipment, some small parts to a production, and also for finished goods. It's an in-house rack with around 50,000 locations in the rack. We have 4 aisles, and each aisle we have a stacker crane. Each stacker crane is doing a performance of 158 boxes in and out at the same time, in and out per hour. And the whole system is able to run around 400 boxes movements per hour. That means 400 boxes in and out. And yeah, we have a conveyor system in front of the mini load. We have different workstations, and it's a concept of goods to man. Around the warehouse, there are different manual operations, like to store half pallets in a manual warehouse. It's just some racks, so there are some equipment and some processes around. But at the end, it's not complex. It's very clear, not too much function. The performance is moderate. So that's, I would say, a very common standard solution we will have very often to solve for our customer. And how did we solve it, Thomas?
Yeah. As Mark said, the customer is located in Germany, and this is not the only automated warehouses at this customer. They are running different other automated warehouses in Germany and in West Europe. They are all controlled by an external MFS system. So 2 years ago, the customer decided to build up the new warehouse in Poland and to store the small parts in boxes, as Mark mentioned. I think we have to go to next slide. Yeah, thanks. To store the small boxes, I said, in this warehouse, and the customers wishes an IT solution to have a standard solution to integrate the other old warehouses, the other warehouse automated warehouses in the solution, and to have a highly integrated SAP solution. So SAP WMSS with our extensions and our add-ons is designed to control such automated warehouse with stacker cranes and conveyor systems and work centers integrated in the conveyor system in a perfect way. The perfect requirements, as Mark said, for handling of fast-moving boxes are the complexity is not so high, but the performance requirements for handling fast-moving boxes is medium to high, from our understanding. So in this project, we have had one big challenge. The idea of the customer to use SAP EWM for the existing old warehouses too implicates that the location for the decentralized warehouse should be in Germany. So we have to check in advance whether the network connectivity between the Germany side, where the SAP system is running, and Poland, where the warehouse is sufficient and stable. To do that, we have implemented an emulation of the PLC level and have tested the communication between the SAP EWM system in Germany and the PLCs, or the emulation of the PLCs in Poland. And we have had good results and positive results. And our recommendation for the customer was to use a decentralized warehouse located in Germany, and we control the first step, the automated warehouse in Poland, and we are able to extend this solution to integrate the other older automated warehouses in Germany too. You see, with this example, it's not necessary or not mandatory to have the EWM system close to the automated warehouse. So we have a communication with more hundreds of kilometers between the two sites, and it runs in a perfect way. This is one example, and Mark will show you the next one.
Yeah, so the next slide will show you another example for a solution which is only partial integrated. That means in some areas we have not SAP. The solution is a little bit more complex than the other one. We have different automated warehouse. We have one warehouse for pallets with one stacker crane, 35 pallets in and out per hour. And then we have a second fully automated warehouse for small parts in boxes. And that is a shuttle solution. So we have 3 aisles, and in each aisle we have 4 shuttles, and the shuttles are able to change the level. So we have quite a lot of levels in the rack, up to 20 meters, and the shuttle cars are able to change the level to pick a box in level 15, and then you change again the level to level 10 and bring a box in level 10 and so on. So it's more complex. And the idea of the customer was to start with a performance of 450 boxes in and out per hour, more or less similar like the other solution we just saw a few seconds before. But in future, he would like to be able to have 1,200 boxes in and out per hour. So therefore, later on, we have to install additional shuttle cars. So at the beginning, there was, as I said, 4 shuttle cars per level, per aisle. But in future, there might be 10 or 15 per aisle, and in future, there will be much more performance. So this project is a little bit more complex than the other one, and we have more requirements to the performance, and also more requirements to adapt the system to future business of the customer. So that's a little bit different than the other one we just have seen. And Thomas, how did we solve it?
Yes, with the next slide, you have an overview about the IT solution. So, as Mark mentioned, we have 2 automated warehouses in this warehouse, two different areas. We have on the one side, we have the automated high-bay warehouse, double deep storage, and we have an automated warehouse for the small boxes. It's a mini with the shuttles, not a mini load system, with the shuttle system, shuttle solution. For EWM, this is not a big issue to control the automated warehouse for the pallets. Also with the double deep storage inside, this is really not a big issue for EWM. So you can solve this with the standard functionalities of EWM, and the performance requirements are really low for such a solution. So the big challenge in that project was handling the small parts with the shuttles, as Mark mentioned. With the shuttle cars, we can bring from one level to another level, and we have 4 shuttle cars in each aisle, and we have more than 40 rack levels. And so we bring the levels for the shuttle trucks from one level to another level and have to organize it. In SAP WMFS, we have no standard strategy for this kind of shuttle warehouses. It's necessary to organize the shuttles, the transfer from one level to another level, but there is no standard strategy available in MFS at the moment. So it's possible to develop add-ons to solve that problem in the EWM system. But there was another decision from the customer. There was a more or less economically decision from the customer to use only for the shuttle control an external warehouse management system or MFS system. And at the end, we have in this project, we have SAP WMFS for the double deep automated pallet warehouse, for the conveyor system for pallets, for the conveyor system for boxes, and only the control of the shuttles is done by an external MFS system. So we have a mixed scenario with MFS for all the things where MFS is designed for, and we have a special designed external MFS system for the control of the shuttle system. And this is the reason we have chosen this IT architecture after different decisions or the discussions with the customer. And at the end, we had this solution and implemented. So with the next slide, I will give you the conclusion of what we have presented with the last slides. To select the right automation architecture with SAP WM is not a general task, so it depends on different criteria which solution is the best for your project and for your requirements. And one of the points, you see it on the left side of the slide, is the SAP strategy of the customer. If there is a SAP strategy in front of in the mind of the customer, it can work with SAP WM. If the customer says, "Oh, it's not the strategy for our company to have SAP in all things running," then you can decide to have an external MFS as a better solution. The location of the SAP system, we have we gave you an example for the customers with the warehouse in Poland is one thing for the decision. A big issue for the system is the performance to control the automated warehouse. With the embedded scenario, it is not so easy to have the performance inside. With a decentralized EWM system and EWM MFS system is a better way to solve the performance requirements. The decision also decides from the partner, from the dependency to your partner, with an integrated or with an EWM MFS scenario, you are quite open to other partners, and you have an open source code, and you can do changes with other SAP partners, and you are not fixed to one partner. With an external MFS system from a third party, you are fixed to the third party company. And another point is the support concept. Do you have an SAP team and you can support the MFS system by yourself as a customer? This is really a good way to handle the support by yourself. Or do you have an external MFS system? You need support from the partner who has implemented the external MFS system. And the last point is really the project budget. If you have really a small budget, maybe an external solution is the better way for your budget than the SAP solution. But at the end, I think it's from an economic view, it's better to have an integrated scenario, an SAP scenario, which you can use your resources that are involved in the SAP environment. So it's not so easy to say what's the right scenario, what's the right solution. This is what we will say with our presentation.
Excellent. Well, thank you very much, Thomas. Thank you, Mark.